안녕하세요. Welcome back to Automatic Control Systems lecture. I am Kalyana Velvolu with the School of Electronics Engineering. In the last class, we completed the stability analysis. Until now, we have gone through the modeling, we have gone through the time domain analysis, and we also studied the stability. So, this until here will be the syllabus for your midterm examination. In the week 7 part 1 and the week 7 part 2 will focus on review problems that cover from modeling to stability. So, the week 7 part 1 and the part 2 will be just the review problems that will help you to understand the concepts. So, this is the first part of review problems. We will first go through with the modeling. So, this is a nice problem. So, if you go through this problem, it's on modeling. So, it is asked to determine the transfer function y of s by u of s of the system shown below. The input u is a displacement input. So, what you see here, the input is provided as u, the output is provided as y. So, whenever you encounter this kind of a problems, first thing is to understand the system. Look at the system and try to understand how input to output signal propagation occurs. In that sense, how does the input influence the output? So, it is mentioned that the input u is a displacement. So, it gives a displacement and then it is asked to measure the y. So, it is the output y. This is a good example of a suspension system that is usually employed in our cars for most vehicles because of the disturbances in the road profile. When the vehicle moves on the road, the wheels are subjected to various disturbances because in the uneven surfaces on the road, humps as well as certain potholes, road inputs can be for various reasons. So, depending on the road profile, the suspension moves to counter the disturbance of the road so that you can feel comfort inside the car. Now, the input is caused because of the force exerted by the road on the wheel. So, if you understand that, this u applies the force to the spring and then this mass moves and this mass is connected to another mass here. So, there is a compression here and this will indeed finally also move y and also the x. So, if you understand this point, then we can actually look at the modeling. So, it is asked to only find the transfer function. So, if it is only asked to find the transfer function, first step will be to formulate the nice differential equations that describe the modeling and then you can actually proceed to apply the Laplace transform and obtain the transfer function. So, when you have this kind of a problem with two stages, there is one stage M1 and one stage M2. So, the good will be to actually understand the system and draw the free body diagram. So, if this is M1, we have an M1 here. So, M1 is subjected to input. So, this is a spring, am I right? So, x is here in this direction. So, there is a force acting on the system. So, the force will be because of the spring will be K1 into direction, very important to look at the direction, K1 into. So, the applied will be K1 into, because the direction is u minus the displacement is also in this direction. So, the relative direction. So, the spring constant K into u minus x. Now, since this is applying force in this direction, the spring and the damping opposes the force. So, the two forces oppose this force. Now, what are those two forces? There is another spring, right? So, actually the direction of motion is in this direction. So, if we actually look into that portion, the opposite, this force, the force applied in this direction will be Kt into y minus x. So, the opposite force which we are acting will be kt into x minus y, and this will be acting in this direction. So, this will be k2 into x minus y, sorry, k2 into x minus y. So, this is k2 into x minus y. Since this is k2 into x minus y, the other one, this is a viscous friction. So, you will have b into x dot minus y dot. So, this is also acting in this direction. So, you have b into x dot minus y dot. So, this is for the stage 1. So, if you understand these two stages, the direction of the forces for the M2 will be in the opposite direction. So, if you are drawing for M2, so the forces acting on the M2 are very simple. There are only two forces. So, the forces will be kt into x minus y, direction will be opposite, b into x dot minus y dot, and y is in this direction. Now, once we write these two equations, then you can easily write the force. I mean, using the Newton's second law, we can directly write the displacement, that the differential equation. So, we know that force is equal to mass into acceleration. The resultant force, that means the resultant force produces mass into acceleration. You see, k into y minus x is in this direction, k2 into x minus y is in the opposite direction. So, what is the resultant force? The resultant force will be k1 into u minus x minus k2 into x minus y minus b into x dot minus y dot will actually give you, is the force acting on it, will result in the acceleration. So, the resultant force produces mass into acceleration. This is the resultant force, that is the force acting on the body. This force minus the two opposite forces. So, you will have m1 into x double dot. So, this is how we formulate this equation. And similarly, we can also formulate the equation for this one, motion equation for this m2. So, if you are writing here, the total force is acting in this direction, there is no opposite force. So, you can directly write k2 into x minus y plus b into x dot minus y dot produces mass into acceleration. Mass is m2, displacement is y, acceleration is my double dot. So, we can actually directly write these two equations, and this is the mathematical modeling. So, once we get the mathematical modeling, that is in the differential equation form, you can next convert it into Laplace domain and formulate the transfer function. So, if you look here, these are the two equations that we obtained here. So, we can directly write these equations. Now, using these two equations, first what we are going to do is apply the Laplace transform. So, since we formulated the differential equations, we can directly apply the Laplace transform for both the equations. So, applying the Laplace transform, we can actually get this kind of forms. So, apply the Laplace transform, so you can separate the differentials. So, you get m1 s square plus bs plus k1 plus k2 dx. So, now you get a function in terms of three variables. The three variables are x of s, y of s, and the input u of s. So, the transfer function is defined between these two. So, then that means you have to either eliminate x1, you have to eliminate x1. So, in a couple differential equations, we might have some intermediate variables. So, when I say intermediate variables, u produces x, x produces y, but our transfer function is y to u. So, we need to eliminate x. So, once we formulate these two coupled differential equation, eliminating x, we can actually form one nice differential equation. So, eliminate x from these two equations, it is like a polynomials. So, we can get one combined equation. Once you get the combined equation, just rearrange the terms and you can directly get y of s by u of s is equal to into this nice form. So, once you formulate the differential equations, it is not a big problem to actually complete the problem. Most students in modeling, most students make mistakes here. Not only on any of this modeling problem, but in any problem, most students make the mistakes when they formulate the differential equation. So, to formulate the differential equation, it is not about memorizing, it is about understanding the physics, the functional aspect of the system. If you understand how the input energy transmits the energy to the output, then you will be able to understand each equations and then formulate the differential equations accurately. So, in the examination, you may not only get on this kind of a problems. I can give you a heat exchanger, air conditioning system, or a car system, or anything. So, you do not need to worry, because most of the time I will provide all the equations. So, if you see, this is the second problem which you are going to discuss now. So, most often we give the system, we give the description, and this kind of equations. So, all the equations will be provided unless the problems are like simple spring mass systems which students can directly model. Otherwise, in most cases, all the systems, all the equations will be provided. If you look at this modeling problem, we have a functional diagram and then a free body diagram, and then the equations that describe the behavior are provided. If students come across a new modeling problem which they do not have any idea, first look at the content and the diagram and then try to understand the system. It is not important to convert the equations into Laplace transform. It is important to understand the function of the diagram. So, if you look at the system, first thing you need to do is, once you read the content, try to identify what is the input and then understand how the input influences the output. So, what happens to the input, and then how the energy is transferred from the input to output. If you understand the whole process, then it will be very easy for you to draw the block diagram and connect all the differential equations. Okay. Now, let us go into the problem. In large disk drive system containing linear actuators, the motion is controlled by a voice coil motor as shown in the figure. So, there is a voice coil motor. So, the voice coil, based on the voice, the coil, there will be a displacement because of the magnetic field. The force F produced is proportional to I in the coil. So, it is saying there is a coil here, and then when the current passes through the coil, because of the magnetic field, it produces force, magnetic force. So, there is a coil, it produces force, and this one will actually move. So, this is the part that actually moves. The link between the head M2 and the servo body M1 is flexible with a spring constant. So, there is a spring constant between the head. So, if you actually look, there is a head here and there is some kind of flexible mechanism. So, that is modeled as a spring. So, these are the mass M1, M2, and there is a spring here. So, the force is this is the magnetic coil here, this is the coil here. So, since there is a field, this actually produces force and this coil actually makes some movement. Now it is asked, draw a block diagram of the system and obtain the transfer function from input AC to output Y. So, it is asked to find the input voltage to output. So, the displacement is the output and the input is the voltage that is applied to the coil. Now, once you understand the system, use also this diagram, which is very important, and try to relate how this system works. So, now if you come here, This is more useful. The block diagram, the functional diagram is very useful. It describes all the variables and all the function and the direction of forces and the direction of displacement is also provided. So, look at here, the input EC is provided, it produces current, current produces magnetic field and it produces force. This force acts on M1. When M1 moves, spring has a compression and it will result in movement in M2. Then there is a Q here, the displacement Q is also proportional to the current. So, this Q here has two things, Q is also a displacement and Q is also used for as a feedback, because the displacement is directly proportional to the current, because Q is also charge. So, the Q serves two purposes here, Q is also displacement and Q is also the charge. Now, students no need to model this one, because the modeling of this one from differential equations will be hard. So, the purpose of this problem is for the students to understand its functions and use the differential equations to complete the modeling. So, I have given all the equations. So, what you see here, all the equations that describe the motion are already provided. So, then the important aspect here is to relate every equation to the functional diagram. So, here there are two equations, the coupled differential equations is calling for the mechanical system. Force F is here, m1 d square q by dt square plus k into q minus y. So, the equation that is covered, force to q is already provided, and then the second equation corresponding to m2 displacement equation is also just a force equation, m square d square y dt plus k into y minus q. That is two equations are provided. Okay, I can understand that the force to y are provided. Next, current flowing in the magnetic field produces F is equal to A1 into I. So, the current is given and the force, the relations are given. Motion in magnetic coil produces the force. So, the magnetic field produces force, E coil is equal to A2 into dq by dt. So, this actually is acts like a feedback, and this is important because it acts like a feedback. The E coil voltage is provided as A2 into dq by dt. dq is forms the charge here. Next, electrical circuit. So, this is the electrical circuit, this is the mechanical part. So, this is a nice electromechanical system. So, the electrical circuit is given. So, one you can see here that this is the input, produces I produces force, force produces Q, Q produces Y. So, if you understand this aspect, the modeling actually is very simple. So, now to me input output relation is EC produces I produces F, F produces Q, Q produces Y. Very important. If you understand the energy flow process, forming the transfer function is very easy. Now, let us go to the modeling aspect. All the equations are provided. So, the only thing the student needs to do is to understand the dynamics and then convert into Laplace transform and complete the modeling. So, first point, take this function, apply the Laplace transform. So, when you are applying the Laplace transform, it is very important to understand what is the input, what is the output in every stage. So, this is relation between force and Q, force and Q. Here force is the input, Q is the output, very important. Force is the input, Q is the output. Force produces Q, Q produces Y, I produces F, EC produces I. So, write this signal flow diagram, signal flow, and then you can actually complete the modeling. So, now once I convert into Laplace transform, I can write in the output form Q of is equal to F of s plus ky by m square plus. So, you can write in this form. Now, for the second equation, Q produces Y, right? Q is the input, Y is the output. So, convert into Laplace transform, I can write Y of is equal to k by into Q. Always write output is equal to in the function of the term is a function of transfer function into the input. Now, the third one, F is equal to A1 into I. That implies here F produces current or current produces force. If you go back to the diagram, current produces force. So, you can write output is force, input is current, A1 into I. So, these three equations are easy. Next, the last one is given is before then is E coil. E coil is like a feedback. Every electrical field systems, when you have two coils, there is, because of the induction, there is a feedback voltage, that is called back EMF, back electromagnetic force is always produced. So, the E coil is given as A2 dq by dt. So, E coil will be A2 into S into Q of S. So, you have to understand E coil voltage is the feedback. So, in the feedback, output acts as input, then that is the only place where we see it is the feedback. So, E coil is equal to A2 dq by dt, E coil is equal to A2 S Q of S. So, write it as input. So, this is the only equation. Many students have a question. So, when you have this question, when you have this problem, you actually keep this equation separate, and then when you link all this one, you will understand that output is becoming an input. The motion in the magnetic field produces the force. E coil is equal to A2 Q2. So, that force and also the E coil, because of that we have this back EMF force. Then let us take the electrical circuit. If you take the electrical circuit, this is the most easiest. So, formulate the circuit, then you can get EC is equal to EC minus E coil. So, the feedback is coming here. So, the equation is already given. So, if you see here, that is how now you can understand E coil is the feedback. Whenever some quantity is directly involved with the input, then the point is it is like a feedback. There is no term before the input EC and there will be no term after the output. So, if there is something that is between input, then it is like a feedback. So, Li into IFS, RFS, EC minus E coil of S. So, I can get this term. So, by getting these terms and by writing all this transfer function, the most important stage is to connect them. So, how do we connect them is more important. So, connecting the terms requires the understanding of how the energy propagation occurs and what is the feedback. Whenever you have all the equations and then you want to formulate the transfer function, that is where you need to think. Believe me, I have been teaching automatic control for 10 years and I have seen many answer scripts of students. Most students do until here, no problem, they understand, they design the transfer functions, but they are unable to complete the block diagram. Block diagram is very important. In a 10 marks, if in a midterm examination I have 10 marks, block diagram will be actually having 4 marks. So, very important that you have to draw the nice block diagram, accurate block diagram. Most students cannot draw the block diagram because they face difficulty understanding what is input, what is output. When you see these equations, they always have a problem identifying the input and output. Now, the easiest way is to first write the signal flow. Once you write the signal flow diagram, we know what is input, what is output. Then you can connect back. Whenever you start writing the transfer function, first thing you do is first write the input as EC of S, and then output I define as Y of S. Then once you write the input and output, important is there is no block before the input and there is no block after the output. So, everything should be in here. Do not go from input, always start at the output, come backwards. So, what produces Y? Q. Identify the relation between Q and Y. So, this is the equation that defines input is Q, output is Y, right. So, use this equation, fill this block. So, I get Q. So, I write, we get this block. Once I get the Q, move forward. What produces Q? Force produces Q. So, what is the equation that produces force? You see here, force is the input, Q is the one. So, pick this one and then write what is inside this one, write f of s. So, I got the f of s. So, then I got these two blocks. Next, when you see this block, you see f of s plus k into y of s by m1 s square plus 2. So, writing m s square plus k is easy. So, I can write 1 by m1 s square plus k. So, I can write this one, but it's written as f of s plus k y of s. So, it is not f of s here. So, it is f of s coming here and then k into y of s. So, y k into y of s. This will be k into y of s. So, k into y of s comes here and will. So, this will be the q. So, understand this term. So, when you have two terms, that means it is a summation. When you have a minus, it is like a comparator. So, use the comparator, that is a summation junction. So, use a summation junction 2 plus. So, this is also plus and then form this block. So, this is where some students may have the problem. When you relate q to f, but you have another output k y of s. So, that is what it happens. So, that means q of s is equal to 1 by m square m1 s square plus k, and then f of s is here and then k into y of s comes here, that actually forms the q of s. Then I have my f of s here, then you can go backwards. What produces f? Current. So, what is the equation that the current produces f is here. So, write I of s, so write A1, you get current. So, the question, now we got the current. Now, what produces current? Input voltage. That equation is given. Ls I of s R of s EC minus E coil. You see, this is like input minus E coil. So, then E coil is something EC minus E coil, EC minus E coil. So, it is like EC minus E coil. Then what is E coil? A2 into S into Q of S, A2 into S into Q of S. So, take the Q1, A2 into S of into Q1, connect it here. So, by doing this one and then by also getting 1 by Ls by R. So, this is 1 by Ls by R. So, 1 by Ls by R you can actually get from the electrical circuit equation, and then we will be able to complete the whole block diagram. The most important is how do you start and stage by stage. Start at the output, work backwards. Okay, never go from input to output, it can be very confusing. So, go to the output and then start backwards. So, whenever you see this plus in the equation and minus in the equation, always understand that it is going to have a summing junction and a or minus will be a comparator. So, if you actually remember these few things and then understand the system and understand its functional diagram, you can complete the block diagram. So, once you get this block diagram, you can formulate the transfer function. So, with this you will be able to solve any problem. So, students, please practice a few problems and then it will be a lot easier to solve any type of problem. So, in the examination I can give you any modeling. I will give you all the equations, I give you a heating system, air conditioning system or any system. You need to understand how an air conditioner works. You need to understand how a heating system works. What is the input, what is the output. I give you all the equations. However, believe me, It is also not easy if you do not understand the working principles. This is not a theory course, it is a practical design course. So, students should really understand how every system works. When you go outside, when you observe an electrical fan, when you observe a refrigerator, Nijango, so you have to really understand how everything works in your home, in the real world. Then you will be able to relate the things we study here to the real things. So, now let us move into a third problem, that is on time domain. So, we have gone through two problems that are based on modeling. Now, let us go to a problem that is on time domain analysis. Time domain analysis is for the standard second order system, step response or ramp or acceleration. Most problems will be on step response, because for standard second order system, step response is very important. So, we are going to worry about the rise time or rise time, settling time, overshoot. So, we are worried about damping and that steady state error performance as well. So, for standard second order systems, for underdamped systems, all the problems that you are going to study will actually work on its time domain analysis. So, given the system shown below, so if you go through this problem, find J and T to yield 20% overshoot and a settling time of 2 seconds for a step input torque T of T. So, try to understand this problem. So, there is a simple a rotating mass which is a rotating thing. So, it has a viscous friction and also a rotating spring constant, and the system equation is given. So, the system functional diagram is given. However, the model is not given, but it is very easy model. If you ask me, the modeling of this one is very easy. What is input here? Torque. What is output? Theta. So, what is the functional relation? So, if you ask me, I can directly write this one. The resultant torque produces mass into acceleration, or resultant torque produces moment of inertia into angular acceleration. So, what is the torque? That is the torque acting, and what are the opposing torques? Spring, right? So, spring will be k into theta, because these two are rigid objects, and then minus d into theta dot. This is for the torque acting and the two opposite torque. So, this resultant torque produces J into theta double dot. So, this is like force equation. Resultant force produces mass into acceleration. Resultant torque produces moment of inertia into angular acceleration. So, we can directly formulate the transfer function for this one, that is equal to T of S minus k to theta of S minus d into S into theta of S, because there is a differential, then I get J S square theta of S, assuming 0 initial conditions. So, output by input is equal to, so you can take the terms, and I get 1 by J S square plus d S plus k, like a m s square plus b s plus k, right? Exactly right. So, this is like a spring damping system that is in the for rotational systems. So, you can directly formulate this equation, and then we can proceed to our problem. So, once we get the transfer function, we complete the modeling. So, the modeling is done, but look at the problem. For the system shown below, find J and T to yield 20% overshoot. So, the overshoot MP is actually specified as 20% overshoot. So, that means we have to relate to the damping, right? Overshoot is related to the damping, and a settling time T is equal to 2 seconds. So, these are the two specifications. So, these are the two specifications, and you have to select J and D accordingly. So, now take this standard second order system, convert it into a standard form. omega n square by s square plus 2 eta omega n s plus omega n square. So, our standard second order system will be omega n square divided by s square plus 2 eta omega n s plus omega n square. So, we need to now compare the system with the standard second order system. That is why you see, if you write, we can write it 1 by j plus s square plus d by j plus s. So, s should not have any coefficients. So, divide the coefficient, write in the standard form and then compare for eta and omega n. So, now comparing these two equations, I can get expression for omega and eta omega n. So, now the two things that are given to us is settling time and overshoot. Substitute for settling time, that is equal to 2. Settling time is 4 by eta omega n. So, if you do that, you will get eta omega n equal to 2, number 1 expression. And then now we have 2 eta omega n is equal to d by j. So, now you can see, you can actually get 2 eta omega n is equal to 4. You can use these two equations, then you get d by j. And from the above equations, I can actually get eta is equal to 4 by 2 eta omega n and 2 by root of j by k. So, use one condition. Second, I can use my overshoot condition. Overshoot is 20%. So, e power minus e. So, use the overshoot condition. In the overshoot condition, is only directly related to eta. For every overshoot, you can find eta. So, for 20% overshoot, I can find eta is 0.456. I got my eta, substitute for eta and get for the j by k expression. So, from that, we can actually easily find the values. So, from the problem statement, we can get k is equal to 5, which gives us j is equal to this one. So, depending on the problem, you can directly solve. So, this is just mathematical analysis, but going back to this problem, what student need to think when you start the problem is, first thing is to understand the modeling, understand what is the input output dynamics, and then try to relate it with the standard second order system, get the equations. Once you get these equations, it's just about mathematics. So, I take the equations, do the mathematics, find the eta omega. So, whenever the MP is given and the rise time is given, you need to relate it to the rise time and overshoot expressions and then formulate the expression, solve the problem. So, in that aspect, in the time domain, you need to remember these simple expressions like overshoot, rise time, settling time, peak time, all these expressions you should also remember. So, with this, I would like to complete this class here. In the next part, we will continue with the review problems too, where we will go through for the stability and some interesting problems also on the time domain analysis. So, this will be the end of this class. This is thank you, end of week 7 part 1. Kansamida.